With the hydrobromic acid that I made in the previous video, I plan to make a bromoethane. Again, this is kind of a failure video, and I'm really pissed about this mistake. The bottle that labeled ethanol actually had kind of diluted acetic acid. Because I got the ethanol labeled bottle directly out of the lab chemical storage, and unfortunately I was wearing respirator at the time, I didn't recognize it was not the ethanol. If you do this correctly with proper reagents, this should work fine. I add all my 350 ml hydrobromic acid and add 150 ml of ethanol labeled mixture. Then I set up a distillation. I used the Claisian adapter arm to work as a fractional distillating column. I did a water bath and maintained the heat under 70 degrees Celsius to proceed the reaction. Bromoethane boils at 38.4 degrees Celsius. And during the distillation, you should keep the temperature below the 70 degrees Celsius because ethanol water azeotrope will come over a lot after this temperature. But the distillant came over about 90 degrees Celsius, so I thought, wait, what? Are you kidding me? And I went to check my reagents with almost no doubt, and I smelled the ethanol and it had a faint vinegar smell. This is one of the most frustrating moments that I ever had in my lab experience. Some idiot put a random liquid in the ethanol bottle and put it in the storage. It could happen because a lot of students use this lab for chemistry club experiments, and not all students are perfect, and me neither. Actually, I was way above the optimal liquid volume that 500 ml flask can handle, and adding additional ethanol would overflow my flask. So I separated the whole mixture into two proportions and distilled each one. This is what I got after all the distillation. I should admit that the yield was terrible. I washed crude bromoethane with sodium bicarbonate solution and water. Then I used separatory funnel to separate. I originally planned to use bromoethane for Grignard reaction, and Grignard reaction in general is quite susceptible to water contamination, since Grignard reagents react with water, ruining the whole reaction. So I used magnesium sulfate that was previously cooked in the oven to dry the bromoethane. So in the next video, I'm going to make bromoalkane using direct sodium bromide and sulfuric acid approach, which is much more efficient and simple. I will explain the whole thing behind this substitution reaction in the next video. I reference a lot from Nurdrage's bromination of alcohol using hydrobromic acid video, so I will leave the link in the description.